Hello, everyone. Just a quick introduction as to how we got here. I was originally reached out. They asked me if I would come speak at this conference. They gave me a bit of a sense of who's going to be there, and then they gave me the opportunity to talk about any topic I wanted. And um, well, I guess my first question was, well, is Bill Matthews speaking there? And they said no. And they said, well, my first request would be I'd want to hear what Bill has to say, because for those of you who don't know, people like myself, I've been in the industry for a long time on the ML side, but specifically about how to use machine learning in deterministic systems, the outcomes of machine learning. But it's only been the last few years that I've been really heavily involved in Gen AI. While as when I did reach out to Bill on my first Gen AI project, and I said, I hope you don't mind, I would love to get your insights because I know you've been in this space for quite a while. His response to me was, Martin, I've been waiting for 6 years for someone to call me to talk about this. So this is our opportunity to share a little bit. And Bill, I don't know if you remember that discussion. Do you want to add anything before we get into it?
No, I do remember that very well. My journey in AI started probably 2016, something like that, from a talk at Let's Test. And I think it was the one that we actually met at,
I believe so.
the very first one we met. And it was just something that just triggered my thinking that actually this is a challenge to how do we test this going forward. And that started me on that journey all the way to the MSc.
Yeah, and Bill threw the challenge down to the rest of the community, and eventually 5 or 6 years later, we started listening to him, and here we are today. So
yeah, it's changed so much in that time. So that's
correct.
A lot of what I said probably back in 2018 probably doesn't apply anymore.
Right. So we don't have a lot of time. So I want to share with everyone how we're going to handle this. Two things. One, there's a lot of different directions we can go into in AI. However, I suspect the area that is the most immediate for everybody who's at this conference is specifically around the space of Gen AI, about using the language and learning models and reasoning models and how we work in this space. And as the topic discussion is about, we're going to talk to you more about like how do you even enter into this space. Being a power user of AI, I pretty much have perplexity in my ear at all times. And one of the things that I did going into this was I gave it a very complex prompt. I went through some of the profiles of the people who were at this conference, and I had it tell me what are the top questions you are likely to want to hear answered. And we're going to try to address those questions here and now. So I'm putting you on the spot here, Bill. So the first question is going to be is, what is the role of a software tester in AI projects today?
Yeah, I can see how that's a good question to start with. From my perspective, testing is needed in these kind of projects, and it's needed for a particular reason. Whether or not we need testers, we can talk about in a bit, but we definitely need testing because we use AI in these kind of systems for a particular reason. That's because we want to do something, we want to achieve some kind of outcome, but we don't know how to do that. We don't have a precise algorithm that tells us how to interpret language, for example, or how to draw an image. So what we do is we use these other algorithms, which are from the field of AI, which kind of approximates the solution to what we're looking for. And some of them are pretty good. But the challenge is that it's that approximation that leads us to this kind of problem area. Because it's an approximation, it's going to be wrong sometimes. And sometimes that's not going to matter, but sometimes that's really going to matter. And as you've moved away from sort of the academic side of it into sort of businesses using this, some of these become really important technical risks. So a technical risk is a risk that's introduced to the quality of the product, in our case, because of the technology we're using. So we choose to use AI, so that introduces certain risks. And testing is all about looking at risks and trying to evaluate and provide information about risks. So in our case, there's always going to be testing around the system, but actually when we look at the actual AI parts of it, we're interested in very specific types of risks. And these are broadly things like bias, fairness, accuracy, privacy, feedback loops, which are really fascinating. And even just those at high levels, we've got lots of individual parts of it that are, or dimensions of quality or dimensions of risk within that, such as the relevance of the output. You've all probably heard about hallucinations, a terrible name for it, but hallucinations are a problem for many companies, not all companies, because if you're doing something creative, it doesn't really matter. But if you're doing something where you want a real answer, sorry, Martin.
I was going to say, I want to interrupt you there on that one because this is an important note, actually. Hallucination. I'm really glad you touched on that. I'm certain many people who are speaking or listening in right now have heard this term hallucination. When Bill says it's a terrible term, it really is, because this notion of hallucination, in human terms, it's you've imagined something real, you sensed it, you believed it, but it's completely made up. And I mean, it can happen. You can have an LLM produce a made up answer. But there is another term called confabulation, which is much closer to what's actually happening.
Mm.
And so a big part of why why a testing mindset is so important in this is specifically because what typically comes back, it's not that it's a made up response, it's that statistically it's possible, but it's incorrect. So it'll always come back with something that makes sense if you consider the question of the request appropriately. However, there was a possibility of other responses, and it provided one of those. And so it is a sense of a confabulation where it is pulling from real data. It is giving a real valid response, just not the one that was intended. And sorry, I hope you don't mind me interrupting, Bill. I just kind of wanted to jump in.
I think it's an important thing.
And
so,
yeah.
So I think, you have all these technical risks, and this is what testing does. Testing looks at a product, looks at the risks that are there, and tries to find some information about it so that people can make decisions, whether that's a decision to go live or whether it's a decision to fix a problem, change something, abandon the whole project. Testing is there to provide that information, and it probably can't be found in other ways, not quantitatively anyway. So I think, definitely in these kind of projects, because you've got this ambiguity or this approximation, you need to understand how significant are some of these problems, and that's where testing comes in. So the question of anywhere in the process where that kind of evaluation of risks happens is where testing has a role in it. Whether that's done by testers or not is another question. Certainly in the UK, where I am, most companies seem to think that the testing side of it is going to be done by the ML engineers. My view is having dedicated people who are thinking about risk and thinking more creatively and have the time to think about it is going to be much more valuable to some of these companies.
Right.
What's your experience, Martin?
So I've worked quite a bit. So just so everyone understands, my last 2 years have actually been spent on the journey of building out technology, specifically from a curiosity perspective, to better understand why things are happening within a system that is a larger data engineering system with aspects of Gen AI at various levels. It's also in the regulatory space. So I sit somewhere in between legal, making sure that we don't get sued, as well as data science, who is very much approaching this from a research perspective of what's possible, with data engineering, who have been trained their whole life to make systems as deterministic as possible, and product, who effectively is trying to unleash possibilities that weren't there in deterministic systems. So there's a struggle that goes on between them. And I think I'm gonna differ from you a little bit, where I would say that it's less that whether or not its testers are involved, but there's a VP I spoke with who told me that there's a real challenge for engineers and data engineers to focus around uncertainty, not so much risk, but uncertainty being an inherent aspect of your design. That everything engineers have been taught is about how to think about your design in such a way that you can constrain it to certain outcomes and detect those outcomes and those thresholds when they happen. What we see now is it's less about risk in the sense that this might happen and we need to avoid it, but rather building a thing that works is doable without as much insight from a software tester or someone with that mindset, like specifically an exploratory tester, someone who's looking to understand what's possible. The part that becomes really, really difficult in the world of companies who are now engaging and trying to build out new capabilities using Gen AI is, how do you build something in such a way that there is no testing period, that new behavior can emerge at any time? It can be a model change. It could be new content being pulled from RAG. It could be simply the structure and the order in which data is retrieved. It could be new contextual information. And given that the issue is not always about we need to make sure this doesn't happen, which can be tackled with something as simple as guardrails, just if you see this, stop this. But how do you even detect that a new pattern has emerged? How do you even detect that somewhere along the way, especially in the agentic models, and that's a whole other discussion that we could dive into at some point. But now that you have the ability for layers of agents planning on how to tackle problems, the real challenge now is how do we design this in such a way that should there be a new influence on how the system decides to go about responding to a problem, can you inform us and provide us with the sort of information that we can even gauge, is this a good thing or a bad thing? What's the larger term impact? Why did this start happening? Why did they start? So this is where the tester, I think, is really the tester mindset. It's specifically an exploratory tester. And it's funny because that huge push of testing is dead that happened years ago because of how much we can do with test automation. Test automation was always about deterministic outcomes, and I don't disagree with them that if you built a perfect system that could only behave in certain ways, you should be able to tell us when it does those things. But now that you have a system that is depending on the capabilities of a learning system and a reasoning system to offer opportunities and options which may evolve over time, no one should ever be asking you again, how much time do you need for testing? There is no testing period. It's about how do we build a system in such a way that if someone is curious about why something is happening at some point and what the impact of that, we've built it in such a way that we can actually observe that, pull that information in. Shout out to Charity Majors, who has always argued that true observability is not having alerts when you hit thresholds, but the ability of seeing data run through your code and see what's happening and understand it. She built a whole company, Honeycomb, based on this concept. This is effectively the challenge now in the Gen AI world. It's about building explainable AI, and that term really means you can visibly observe new emergent behaviors and try to make sense of it, add more angles at it, explore more, and discover what's possible. So, by the way, time check, Bill. We're up at 12 minutes already. We're only through the first question, but I do think this might be an interesting segue then, because the second question that popped up was, where does testing then fit in into a modern AI development process? So it's related. We kind of touched on it, but where does, if you are an expert in testing, and I've just stated there's no testing phase anymore, that there's no period where we build a thing and then we test it. So where does a tester actually exist in a company who has now embarked on building products that are leveraging, and again, we're going to focus on Gen AI. How does that fit in, and where do you start finding yourself working with teams? What have you seen?
Yeah, so I mean, a lot of it is during the build phase. So when I'm thinking of build isn't just I shouldn't use the word phase because it's not a phase. It's the initial build, and then it's a continuation of build for forevermore until the end of the product. You're always evolving that product. But as you're evolving a product from our very first idea, there's always an idea. There's always something we need to be checking. We need to be seeing, how does it behave under these circumstances? Is it a problem for us? And so there's a role for that kind of testing and exploratory testing about the different risks that we care about as a company to try and help guide the development. So if you think about that in traditional terms, most of us are probably system testers, so we tend not to get involved with unit and integration type tests that the developers do. And then we get given it at the end of when they've finished their testing, whether it's finished of a story or a whole product or a phase of work, it doesn't really matter. I generally observing that for Gen AI projects, you're tested right out the box. You have to start testing. You have to start thinking about testing when you're actually thinking about what are we trying to do. And testing itself can help guide that development work in terms of, do we need a guardrail? Do we need a fallback position for this? Is it that serious a risk that we need to say, if we find this, just stop processing? Or do we need to add more controls into that? And controls are a bit like business logic, but not just code logic. They could be another model. They could be a sequence of models, back and forth loops, and also crazy things like that. The testing can help guide that because it identifies we probably need this. We've seen this. We used these behaviors and we tested that. We got some results. We've looked at it and we think we need to avoid this or try and mitigate it in some way, or at least be able to observe it later on. And I think there's a key role there for testing in terms of how you build a product and how that product evolves over time. But there's a lot more to it. And I think, I'll pass over to you because you've been talking about the observability side of it. And I think that's another very key thing.
Everything I have on this is just a yes and. Certainly where my team has been most involved, when we started working on this problem, terms like explainable AI didn't exist yet because there were no approaches. It was one of those very interesting situations where the people who were the most knowledgeable people in the world were maybe about 4 months ahead of us, which was unique for me.
Mm.
Specifically when guiding a team of engineers, I've rarely been that bleeding edge on a technology. Um, but I would almost say that it, it's like you're trying to. I like the idea that you're saying that it's about the design, but the design's almost not even about testability. It's almost about just, have you created the ability to dismantle and observe and separate and reconnect in different ways? Um, we have been involved in the project before a technical design has been written, where I've actually personally really upset a product manager because, given what he was wanting to build, my agreement was, the thing you are trying to build is an excellent project, but please have a look at the data I've used. And I had built 6,000 prompts and had run through it. And I demonstrated to him, it's like, we can build something that works within your paradigm, but we have no ability to then, with with fluid questions coming in and fluid sort of problem statements coming into the system, of detecting if it would to stop providing accurate information, because there was so much complexity in the ask that the ability to actually detect a pattern that was incorrect advice. In my case, I work for a company. I work for Credit Karma, and the company that, you know, we have a very, very strong emphasis on not providing any advice or any data to someone that may be harmful to them or create risk that they don't want to go. So the bar is extremely high, and the lawyers, I work directly with them, but I also work directly with all the problem owners and the GMs. We would never put something out there if there was a risk that they might give someone some poor advice, and we couldn't prove that the advice in the future would still continue to be the best possible option on some of the offerings that we had, based on this particular engagement that this one product manager wanted to do. It was extremely ambitious. I think we'll get there someday, but the technology is not there now to be able to detect that. In fact, if we revisit now, it might be. So we managed to shut down an entire project before an engineer even had a chance to try to write up how we would build it, because we had already explored the possibilities of how one can detect this, and it wasn't a guardrail problem. In fact, just speaking about that, if you've heard the terms about guardrails, it's like a hammer. A guardrail on the input side is just never let this happen. A guardrail on the output side, never let this happen. But it's kind of like your last resort, and it's the sort of thing that we as testers are trying to help the company avoid doing. What we're trying to do is help nuance the decision making and nuance the way that we ask questions, the way we write prompts, the information that's provided to agents along the way, such that not only we can help them get to the closest possible question they're really trying to answer with all the right domain knowledge, they won't conflate two different pieces of information, and more importantly, we're not trying to fix bugs, because they're going to happen. Like, this is the other part. It's going to be very hard for everyone to understand. The days of trying to release bug-free software are gone, because you can have zero change in your code whatsoever, and just a data set somewhere changes, or even potentially nothing changes, and a new emergent problem starts to exist, even just based on different questions being asked because of what's happening in the public stage that you had never considered when you wrote your product.
Mm.
So this day of how do we release with no bugs is not a testing problem anymore. What the testing problem is identifying, how does the system behave to new types of questions? How will it inform us if it's done new things? And so we are in many ways evaluating how clearly we can communicate with our system to that, so it can best inform us about how it's behaving, and is it behaving in the way that we like. You can almost, it's like our prompt engineering is almost a sense of like, how do you put the LLM in the mood to answer the question the way you like? Because it can answer all sorts of different ways. I heard somebody mention that before when talking about adversarial attacks. How do you put it into a mood to tell you things it's not supposed to? So this is where I think it's really changed, that it's not even a case of shift left. The tester now inside of a project is an advisor along the whole way around, how do we manage uncertainty, and how do we build trapdoors and catches and logging for problems we haven't experienced yet, but but just knowing that wherever it might occur, we have the ability to learn more about it, and we have the ability to adapt.
Yeah, I mean, I think in terms of guiding the development, the sort of testing I was talking about earlier, that's kind of like looking for your known issues, the known kinds of problems you want to try and avoid at some point. But there's this wider problem about emerging behaviors and the complexity of these systems that means that there are problems that we haven't even thought about. And I think, we do need to have these systems in place that are designed to help us understand what's happening,
Right.
catch them if we can, manage incidents if we have to,
Sure.
if it's serious enough. And I think that's often overlooked, certainly in large companies. I think with your company, you've been doing this for a couple of years now, so you're already sort of experiencing this, and you'll say, right, how do we solve that? But I know a lot of companies who are starting now are just thinking, no, I need to get a product out there as quick as we can,
So
and hope for the best.
I'm going to stop you there because you've managed to find your way into a segue into the third question I had. And I want to make sure, it looks like there's a mountain of questions that have happened there. So I want to make sure we get to any questions that bubbled up that people want to ask us. But if nothing else, if I were attending this conference, I'd want to have one thing come out of this session, which is I'm an experienced software engineer or a software tester, but I'm about to engage. I want to prepare for working on Gen AI projects. Where do I start? It's really easy once you're in it, but where do I start? So, coming from you, Bill Matthews.
Don't do what I did, which was spend nearly 6 years trying to. Personally, I like to get into the details of things and understand how things work. So that's why I went down that route and ended up with a master's degree. At the time, that was kind of the way into getting these kind of roles. Now, I don't think you need that. But I think the one thing you do need to know, if you haven't already been doing that, is get familiar with Gen AI, get engaging with it. Start using it on a day-to-day basis to try and learn about it. Microsoft, Amazon, and Google all run an introduction to generative AI, which are good things to go through. They're free. They help you understand where Gen AI is with a slant on their kind of products. And as part of that, you'll learn a bit more about prompt engineering if you've not done that. So I think, at a very minimum, you need to understand that. For me, I find understanding the sort of higher level architecture of the AI in terms of the functional components that make it all up are really important to try and understand it from a testing perspective. You don't necessarily need to know how a large language model is trained or a foundation model is trained, but you need to at least know what, when we're talking about guardrails, what a guardrail is, what RAG is, what CAG is, what is, all the new things that are coming out at the moment. So you have to sort of get that kind of high level feeling. And I think for me, the tipping point for me in terms of getting involved with this was really focusing on technical risks. Trying to understand, given this system, what are the kind of risks that as a tester I should be trying to tackle and should be trying to think about how I solve those problems. And I've also leaned quite heavily into what's known as responsible AI, because I think for many companies that's a practice that they're going to, that they need to take to build responsibly and ethically. And there's quite a crossover with testing, because a lot of the things about responsible AI is things like bias and fairness. And the way you know whether or not you're being responsible is you test, and so testing has a crossover with it. So they're the sort of initial things that I would do is to get there. But then it's about practice, and that's a little bit harder to do. Trying to get into if your company's not running these kind of projects, and you want to hone your skills, you need to be looking at, can I build my own models and test them, experiment? Are there public models I can test? Can I volunteer on a project that allows me to get some experience? And if people are looking to volunteer, I did some work with a company called Omdina, which we'll make a link available. They have sort of projects for social good that you can join in on, and you can join in as a tester and contribute that way, get real world experience of it. But I think that they're the sort of key areas that I'd focus on. What about yourself, Martin?
I'm just being conscientious of time that I'm being told that we have left. I'll just build on that. The comment about architecture is extremely important. You don't have the luxury of looking at one end or the other anymore. You need to start learning about not what does it look like now, but rather how to start interpreting new forms of architecture. If you looked at how systems were built 6 months ago, it's not even touching that right now. We're on the agentic approach right now, but you can start looking at agent 2.0, agent 3.0 approaches. They'll be building out over the years. Reasoning models are becoming quite more complex. I personally feel that getting into training models might be a bit much. I don't think that that's needed. And I'm going to say something that'll be potentially uh, somewhat disruptive to some conversations, but I think it's super important that you learn Python. And the reason for that is if you want to be able to build out your own little projects, hitting an embedded AI using a software like Together.ai would allow you to have a single, like Together.ai gives you the ability to have a single API key and then choose what type of model you're hitting on the other end. And then you can start using either Cursor, or if you want to even get further removed from the code, you can use tools like Replit to try to build a project based on something you think you might be able to use and try to iterate on it and then allow the system. It's not going to tell you this is the best way to build a product, but it will build the product using current practices. It will source how people tend to architect these, and it'll allow you to start looking at the code, and then you can start playing. If I want to build in the ability to test this at different layers, if I want to build in the ability to build an evaluation tooling to pass data through, you can start playing with it. And the more you personally play with the challenges of knowing how to build a system where you can predict what the large language model will say, and the more you learn how to ask a broader sense of questions that can challenge it with nuance and bias and hidden bias, the better prepared you will be for projects that are coming up, because you've now taught yourself how to think about a problem you've never seen before and how to make sense of it quickly and figure out how to start asking questions where people are not looking. Because the engineers are always going to be thinking about, how do I get this to the point of completion? Your job is to ensure that once we reach that point of completion, we haven't done so with deep regret. That's really what it comes down to. I just want to do a time check with our hosts. I think that I was seeing time left and that you also wanted to ask some questions.
Yep. Just a second. Folks, we can take one or two questions. We have a hard stop at 8:40. Okay.
Okay.
Martin, do you want to pick any of the questions from the Q&A tab?
You are asking a person with ADHD to mine a sea of questions. I think it's a terrible idea.
Okay. So I'll pick. Swapna is asking, where testing intersect with intelligent systems, how can I accurately access my current standing, learning progress, and applications depth in AI testing? It's a very big question, Swapna. Really sorry, but I'll have to skip that. What tools and frameworks would you recommend for beginners in AI testing?
I've definitely named two there. Replit is a wonderful one to start playing with. It's more important to start putting a system out in front of you that you have some concept as to how it was built. You can actually interact with an AI agent to build something and do something as simple as like, hey, I want to know where the closest taco stand is to me and wherever city I'm in and whether or not they deliver. And you just build a tool that does that. And then you start changing it, adding layers and playing with it. But from that, you'll start to understand how you might want to build pieces in. And you can say, I want to add a guardrail to prevent this. I want to sanitize the data. I want to start referencing other documents that can pull in this information. So, and from there, you can start asking better questions about where to look. But just to be clear, AI is the great equalizer right now, that you're not going to be limited to the things that you've had experience with about how you can perform. Where you will have the biggest advantage as software testers right now is the real power in the Gen AI world is understanding how to ask the right questions. And you all already have that. Everyone has access to that same massive body of experience now. Knowing how to formulate the question in such a way that you get the answers in a way that they speak to you based on your current knowledge level is the skill. Bill, I don't know if you want to talk to that.
I would probably add to that in terms of tooling. I would say if you're looking for ways of tools for testers, I'd definitely look at the tools around evaluation. So there's great tools from evidently.ai, Gizguard.ai, Galileo.ai is really interesting with some of the ways that they're using agents. Another one called Ragas. I don't think that's an AI. I think it's a .io.
Yeah.
I think they're good tools for testers to start learning. It gives you some interactions with the LLMs and the processes around building evaluations. and the challenges around it, which I know we haven't got time to talk about that, but we could probably fill another 40 minutes on that.
Yeah.
Yeah, I would just add to that quickly that if you get access to those repos and you can install them yourself, you should absolutely try to fork and try to extend upon them, because what you want to understand is how to extend the evaluation approach, not just use what's been built for you in this case.
Interesting. Awesome, folks. Since I wish I had a chance to ask all those questions which were there from the attendee side. So yeah, thanks a lot, Bill. We'll surely do one more session with you folks. Really enjoyed your conversation. Thanks a lot, Bill. Thanks a lot, Martin, for taking out time and
Absolutely. Pleasure.
giving this amazing chat. Folks, I'll request everyone to join the next session. I'll see you in the next session itself. Bill and Martin, thanks a lot once again.
Thank you.
See you soon. Yeah.
Have a
Take
good
care,
day.
everyone.